Okay, welcome back to the white box stage. Now we are slowly getting tired, but please don't be, because this is a really, really cool talk that's going to happen. Why? Because the speaker's iPhone has just been connected to the thing. What does that mean? It means live demos. It means high risk, but still it's going to be super fun. So we're going to see things actually happening live here. What are we going to see? So our speaker, Milan Todorovic, will show us how when you have three things, data, good idea, and an Apple Mac, then you can actually develop an end-to-end AI app for iOS. So please welcome to the stage Milan Todorovic, Swift and iOS trainer and software engineer at Crossover.
Hi, everyone. It's good to see you. My name is Milan, and today we are about to talk about machine learning, something about machine learning. So I will talk about Apple's way, Apple's approach to machine learning. The main topics we will rely on are Swift, programming language Swift, then iOS as operating system. How many of you have iOS? Okay, good to see. Okay, then Xcode, which is actually development tool to develop iOS apps with programming language Swift. It is not only for Swift, it is for Objective-C too, but we will talk about Swift. Actually, I'm not about to talk too much. I will demonstrate. I will make an app which will use machine learning. And we will talk about CoreML. Not only about CoreML. Later, we will speak about CreateML as well, but we will start with CoreML. What is CoreML? It is actually, it's been published 1.5 years ago, in June 2017. And the main idea behind CoreML is very simple. Grab the ML model, machine learning model, drag it to Xcode, and with a couple of lines of code, put it in your app, which you will start on your iPhone or iPad or whatever. Actually, when we talk about model, what is model? It is millions of parameters. CoreML takes care of performance. It uses CPU and GPU, and the CoreML is doing this in optimal way. Very important thing, it works on device completely. So no data is sending out of device, which is very important. You know why? Because these apps are privacy friendly. And it is highly suitable for personal use. What does it mean, personal use? It means it works on your mobile device, first of all. When I say mobile device, it is iPhone, it is Mac Watch, it is Apple TV, Mac OS. Okay? When we talk about apps, when we start with CoreML model, it is actually one file which uses the CoreML in the middle of the screen, and we put it all in our app. Our app will receive our app will receive some input and will infer what it has to infer from the model. Okay? Oops, something happened in between, sorry. Okay. So data in-app data is coming, and our app will infer, will estimate, or whatever it has to do. The main question is, where are these models coming from? Apple offered two ways, two options. One was to use one of ready-to-use models, which are popular worldwide. We are talking about MobileNet, SqueezeNet, PlaceNet, GoogleNet, ResNet, VGG16, and so on. So I believe some of you are familiar with these models. But another option, which is probably more important, is that Apple enabled usage of some additional tools made by some other players in the field of machine learning. I'm talking about IBM Watson, about Turi, about TensorFlow. So Apple enabled usage of ready-to-use model made in some different tool of some different company, and Apple gave us CoreML tools as well that enables conversion from model of that type into CoreML model, which will be suitable for iOS apps. I will just demonstrate in few minutes how all does it looks like. The first block is accelerate. The second one is BNNS. What is accelerate? Actually, it provides high-performance, energy-efficient computation on CPU. Metal performance shaders. I will show it. Sorry, just a second. Yes, BNNS, basic neural network subroutines. It is actually a collection of functions that use to implement neural networks. Metal performance shader is responsible for GPU. What is important about CoreML? It is that CoreML uses CPU and it uses GPU. It is all about performance, all about high performance, all about using hardware in a most optimal way. Okay. Another block is CoreML itself. It relies on accelerate, BNNS, and metal performance shader. On the top of CoreML, Apple built 3 blocks: vision, natural language processing, and gameplay kit. Vision is for, of course, image classifying. It is for face recognition, face landmark recognition, and similar things. But in addition, vision has been used to make image classifiers. I will show you a little bit later how exactly. When we talk about natural language processing, it is about analyzing text and deduce its language metadata. It uses natural language framework for script identification, tokenization, lemmatization, and other important things related to text analysis. And the third one is gameplay kit, which actually enables the developer to make better game logic. It actually enables to give intelligence to the characters in the game. And the next important part of this equation is create ML. Why is this important? Because in last year and a half, it was not possible to make model in Apple's way. As I mentioned already, it was possible to use some tools, some libraries from other players and convert it. But now, in the last few months, we have create ML. And when we talk about model creation, we start with data, of course. And data can be in one of three possible use cases: images, texts, and tabular data. This is what we have now. From data placed in a tool, we will get the model, and we will evaluate this model all using CreateML. If we are satisfied, we take a model and use it with CoreML. If we are not satisfied, we can add additional data and to improve accuracy of the model. Okay, so let's talk about use case one. Let's talk about images. So let's say that we have big data of images, a lot of images. And if we put it in CreateML, we will actually be able to get the list of labels and probabilities on the topic, what the machine see on the picture. And let us see the demo. The first, I will connect my iPhone to the computer. Okay? And, oops, I hope you see this. Okay, this is my iPhone. Okay, you see it is, definitely. Okay. In addition, I will show you something for my images. Okay. Okay. So what it is? Chocolate. Another image of chocolate. Okay. And chocolates and so on. So what else? Another type of chocolate. I'm sure you cannot recognize this. Some of you, yes. But this is chocolate from my country. And what we got more, it is spice. It's chili. Okay. And I will show you a few more items. So give me a moment. Okay, here it is. Here is a jar of Nutella, chocolate, you already see, another chocolate, here's chili, and chewing gum. Okay, why do I need this? Because I have all these images here in this training folder. What you see that I splitted, that I placed images here, images of, okay, what is this? It is, okay. So what actually I did, I made 20 images of each type, and I splitted it in 80-20 relation. 80% is of images, so 16, is for training. Other are for testing. And now I will start the machine. And okay, just a second. I will open Xcode, and it is the tool called Playground. So, as you can see, I have only 3 lines of source code here. Actually, I made one object which is image classifier builder. What is image classifier builder? When I start this code, okay, few moments, we will see something here. Okay. Okay. Okay, here it is. Trust me, I was sure it will happen. Okay, so what I have now, I have the place where I will put all these images. I will put the whole folder. Which folder? The training folder. Okay, and what is the classification? The names of directories are the classification. So each directory contains images with its own label. Okay. I'm putting it here. Okay. And okay, the process started. Okay, so you see actually previews of images, and we are actually training our model. So it will not take too much time. It's actually a couple of seconds. Okay? Of course, I agree, it is not too much images, but never mind, you will see this model will work. Okay? Now I have some model trained. Now I will use the rest of data to check whether my training is okay. I simply do not have too much time to describe all these numbers, but trust me, it is very important. But okay, it works, never mind. Additionally, I will put test folders, which are practically in the same structure. And here it is. And all the system is checking whether this is okay or not. I will not get very high evaluation level. I believe maybe 80% or sort of. Okay. Okay, it will have, okay, it's 80%, yeah. Okay, but of course, if you are not satisfied with this level, you need to increase the number of images. When we talk about realistic systems, we should use thousands of images, dozens of thousands of images. But the most important thing, you can check in an easy way what is the probability that you are right, that your model is being trained well. So this is a very, very important tool for that. I have some additional options which I actually cannot cover to improve the accuracy of the model. I can use flipping of images, splitting images, rotating, and similar tools, but some other time. What can I do now is to save this model. I hope you see this. So I will place this model in one folder. It's this folder here. So I will save it and take a look. The name is imageclassifier.ml model in documents folder. Okay, I have 12 minutes more. And so just to show you how does it look like here on the desktop, here on the documents. Okay. Data created. Oops. Image classifier model. Okay, so 549. That's it. Okay. I will just open this to show you what we got. Please take a look to the size of the model. It is 66 kilobytes. It is, of course, we are talking only about five items, but it is really low. I hope you agree. And what is the input? The input is image. What is output? It is a pair of key and value. Key is string, the value is probability, and it is of course double. Okay, we have a model now, and I have the same model in my project. I will open the project. Okay. Okay. And here is the model. I renamed it W image classifier. W because we are developers. And you see this is the same model, which is 66 kilobytes of size. And now I will start this on my iPhone. So I hope you will see this now. Okay. Okay. So here it is. And I will start it on my iPhone. Okay. See here, it's preparing for start. It's building, installing, and so on. Okay. And I hope it works. Yeah. Okay. It is actually placeholder source code. So I just placed a button without renaming it. Okay. I hope it is not a big issue. But I will take a picture. Okay. So, okay. Okay. This is Milka. Use photo. Oh, it's chewing gum. Okay, it is because light. Let's. Okay. Okay. Oh, it's chili spice. Okay. Okay, I made a mistake just to show you that I'm doing it really. You know. Okay, sorry. Let's see how it's going with this jar. Okay. Oh, for some reasons, chewing gum is is on the highest priority. Let's check again. Okay. Okay. No, Nutella. Okay. Okay. I believe I know what is the reason, because the level of training is low. I usually check marks related to rotating images, to use noise, blur, and so on. And it increases accuracy a lot. Of course, you cannot expect that you can make app that will predict everything with 100 images. Of course, you need much more. But what I suggest you is to try. As I mentioned, you will be able to be sure what is the percentage. 80% is not too high level. Okay, and let me check again. Okay, let me see what's going on with chewing gum. Okay, it is definitely chewing gum. What is about another chocolate? Sure. Okay, best wishes. Yes. You know, this is the translation of the title of this chocolate show. So probably it will be about 80%. But please keep in mind that I made it here everything in 20 minutes. So it is not about hours, it is about minutes. It is not about minutes, it is about seconds. Keep in mind that this is a very good way how you can quickly go out to the market. If you have customers and customers have data, you can offer app that will analyze this data quickly. And the most important thing in this case, you will be able to predict how accurate you will be. Thank you. Okay. Thank you very much. Okay.
So thank you, Milan. That was really interesting, and I hope we have a lot more interesting questions on Slido. If you haven't had time to post your question on Slido yet, please do so with the hashtag AIC18. This is the white box stage. So let's go with the first question. Why should I convert my TensorFlow models to CoreML and not use TensorFlow Lite directly?
I believe you should use TF Lite directly. Why not? You can do it, of course. And I suggest you to use Swift for TensorFlow, definitely. Yes. I'm in love with Swift, definitely. So I can say that I suggest you that if you already use TensorFlow, if you are already aware how to do it good, you should use TensorFlow. The most important thing is that in this case, that your data stay on the device, But if you can do it with TF Lite, definitely you should use TF Lite.
Okay. Then I guess this is, let's say, the lightweight version. Can you share the source code on GitHub or something else?
Yes, definitely. I will do it. I will do it. So yes.
Perfect.
Yes, definitely. You can expect this. You can expect that I will share data, that I will share description, and everything else that you became able to do the same thing. Of course, you can use this approach to make some additional type of app which will recognize objects. Let's say in museum, you see this. This is a great place for this. If you can make images of monuments and to make your application able to recognize, let's say, monuments. Okay.
Perfect. I think it's related. So is there actually an available tutorial for us to try this demo at home?
Okay, so I will definitely, as I mentioned, I will definitely put it on GitHub soon, in a couple of days. But what I suggest you, please take a look to WWDC videos on Apple's website, where you will see practically very similar things. Just one, okay, just few more words on that. I wanted to demonstrate you real thing. Until a couple days ago, I had a plan to demonstrate here some classic type of example, let's say cats from Kaggle or something like this. But on Sunday, I entered to the shop and I took these 5 items just to make things real, And just to mention that this is the second Nutella, it's not the first one, because my kids ate the number 1. Okay.
Perfect.
Thank you.
So actually, I think these questions are coming up because of the chewing gum thing.
There was an interesting question. Can you go back? Okay.
Can we go back to the?
Did you? Oh no, here it is. Sorry. Did you try?
Because I think what we had was, 2 questions, which was related. The second one, how many images do I need at least to get good results?
Trust me, I had better results with this. Of course, it is always the question. It is, of course, regular questions, and it is always the question. But you should increase the number of images until you get good result. What you will consider a good result, 92, 95, 97, it depends on you. But it is about probability. So my answer is try and follow what will be good number of images. You will not get the common answer to this question.
Perfect. And the question that I like a lot, can we get the best wishes after Q&A?
Yes, of course. Yes, who asked that? Of course. Okay, who will come first? Okay, here it is. Here it is. You can get najlepše želje, you can get Milka, you can get Nutella as well, chewing gum, of course, chili as well.
Perfect, perfect. Now, so we're running out of time, so we'll have to close here, but Milan will be here, so if you have any further questions, especially specific questions about how to do this, how do you really get a tutorial, what is his GitHub, so come up to him and ask questions, and then you probably get the chili.
Thank you very much.
Thank you, and we will regroup at
Everything is here.